So let's summarize displacement, velocity, and acceleration and how they're related to each other. Let's go to the first question here. All right, if the d is positive, meaning you're to the right of the house, and the velocity is also positive, meaning you're heading towards the right, are you moving away or towards the place of origin, meaning the house? Because they're both positive, you're going to be moving away. Number 2. If they're both opposite signs, so what that means is you are to the right. So imagine you have a house and you are to the right, all right? And what happens? But you are moving which direction? You're moving to the left. So that means you're moving towards the house, so towards. Number 3, over here you have a house, and right now your displacement is negative, meaning you are actually standing to the left of this house. But what is your movement? You're moving, because velocity is not 0, you're moving to the right. So you're heading this way. So you're heading towards the place of the origin. Number 4, again, you are to the left of the house, but right now you're not moving to the right, you're moving to the left. So that means the distance between you and the house is going to get further. You are moving away from the house. So recapping the previous slide, when you have velocity and acceleration in the same direction, so imagine Mighty Mouse pushing you in the same direction, you're going to speed up. If velocity is to the right, but then you have a force against you because the direction is opposite, you're going to slow down. If velocity is to the left, meaning you're heading towards the left, but then you have a force against you because it's going to the right, you're going to slow down. Over here, you're heading towards the left, you're moving to the left, but then you have a force that's also moving in the same direction, pushing you, meaning you're going to actually speed up. So I'd like to talk a bit about the misconceptions about accelerations. Some people think that if acceleration is negative, it automatically means slow down. Or if acceleration is positive, some people think it's automatically speed up. And this is not the case because we already established a sense of direction for velocity and acceleration. So keep in mind, if acceleration is negative, it doesn't mean that you are slowing down. It really depends on the velocity. So if velocity is negative and acceleration negative, you're going to be speeding up. But if velocity is positive and acceleration is negative, then you're going to be slowing down. So just be aware. Same thing with the acceleration is positive. So just because acceleration is positive, it doesn't necessarily mean you're speeding up. It really depends on the direction of your velocity, where you're heading towards. So just be aware that if velocity is positive and acceleration is positive, then yes, you're going to be speeding up in this direction. However, if velocity is negative, meaning you're going this way, but then you have acceleration going against you, you're going to slow down. So here we're going to analyze every single signs of the velocity and the acceleration. So keep in mind, acceleration is the change in velocity over the change in time. It's related to the slope of the velocity. So let's look at the velocity. This entire red part here, the velocity is positive. That means the speed is positive and you're going towards the right. Over here, afterwards that, you have velocity is negative. That means you're going to the left. So what that means is you're to the right, but eventually after this point here, you're going to change direction. But here, change directions, meaning you're going to turn. Your car is going to turn, or you're going to turn around. All right, now that's what's happening to the acceleration. Remember, acceleration is the slope of the velocity. So let's check the slope of the velocity. Slope of the velocity is, notice here, the slope is positive because the velocity is going up. So, but here, acceleration is positive. Over here, acceleration here in this area, the slope is negative. So acceleration is negative. And what about over here? At this moment here, the acceleration, the slope of the velocity is at a turning point, meaning the acceleration here is going to be 0. So what's going to happen afterwards, we'll come back to this later on in another video, but what's happening afterwards here is acceleration is all negative here. Because why? Because the slope is always negative. Look at the graph from here all the way down to here. The slope is negative. In other words, let's have a look at the velocity. So velocity is positive, positive, positive. Velocity is negative. But over here, velocity is 0 because it's on the x-axis. So what's happening to this, to you or to the car? So notice here, this area here, what I'm circling here, you are speeding up. So over here, speed up, you're gaining speed. But eventually afterwards, what's happening here? You're going to slow down. So over here, this dark area here, because you have V positive and A is negative, you're going to slow down. And what's interesting at this top hand part, we might as well address it right now, is This is the point where you change your mind. For example, you're pressing the gas pedal, and eventually, let's just say you see something and you have to step on the brakes to slow down. This point here is called we'll talk about this in future lessons, is called the inflection point. It is the point at which you change your mind. Instead of speeding up, you slow down, or vice versa. Let's just say you slow down and then something happened and you decide to speed up. That is your inflection point. We'll come back to that later. So over here, what happens now afterwards? So let's use the gray one here. So at this point here, this arrow here, so you are slowing down up to the moment where your car stops for that instantaneous second, that's really quick moment. And what happens afterwards? Oh, you're going to take your car and go reverse. You're going to go in the other direction. You're going to turn around and take your car and go in that direction. And what's going to happen to your car? Well, in order to go from 0 kilometers per hour to a certain speed, you're going to have to speed up. So let's look at a different type of graph where it's like a parabola facing up. So notice here the velocity is all negative. Velocity negative, velocity negative, but in this red part here, the velocity is 0, meaning the car's not moving at that moment, or you're not moving. And over here, this upper part here, the velocity is positive because it's in it's above the x-axis. Now let's look at the acceleration, which is the slope. This entire area here, from here to here, acceleration is negative. So I'll put here A is negative. But from here to here, all the way up to here, this dark part here that I'm trying to trace here, no matter what happens, the slope is always positive, or the acceleration is positive. A is positive, A is positive, A is positive. And over here, what's happening here? Well, in this case, the acceleration is neither negative nor positive. A is actually neutral, 0. So what's happening to the story here? Well, let's have a look at the beginning. So I'm going to trace yellow. So yellow means that the car starts at 0 kilometers per hour, but it's heading which direction? It's heading always to the left. So it's going to the left. It's actually gaining speed. Why is it gaining speed? The signs are negative, and you can see that it's starting from 0 to example 9 kilometers per hour. So you're gaining speed here. So you reach 9 kilometers per hour heading to the left, but eventually what happens? You're going to change your mind, step on the brakes or release the pedal, and what's going to happen to your velocity here, or your speed here? It's going to actually get smaller to the point that your car stops at that split second, but you're still heading towards the left in this yellow part here. But what happens afterwards in the red part here, you're no longer heading left, you're actually heading towards the right. So after this yellow dot here, you decide to turn around, move towards the right, and gain speed. You're gaining speed. Both velocity and acceleration are positive. So this is just like a recap of how the displacement, velocity, and acceleration are related. So velocity is the rate of change of the displacement. In other words, V, we'll call it velocity, is the change in displacement. Or in other words, d prime t. Now over here, acceleration is the rate of change of the velocity. So acceleration is delta V over delta t, or V prime. So let's do an example given not a graph, but an algebraic representation of a graph. So here we have a cubic function, and this represents the position, or a popular letter is S, or you can call it D for displacement, but S is the more popular letter to use. So this is the position function. So to find the velocity, so we're going to answer some questions. Let's find the velocity. Now velocity means what? It is the derivative of the displacement, or your position graph. In other words, we're going to have to take the derivative of the cubic function by using the power law, and you end up getting a quadratic. Next one says, well, what is the velocity after 2 seconds and 4 seconds? So you take your velocity here, and then you substitute the 2 seconds, and you substitute the 4 seconds, and at the end you get some sort of answer. And we end up getting, after substitution into the velocity function, the parabola quadratic function, we end up getting 2 answers. So what this means is, at exactly 2 seconds, what's happening with this particle or car or yourself? Well, it means that you are moving to the left. You're moving west at 3 meters per second. Now at 4 seconds, what's happening? Oh, you're moving towards the right. You're moving east at 9 millimeters per second. So when the particle is at rest, resting means not moving or your speed is 0. In other words, you want to take your velocity function and set it to equal to 0. And all you have to do is use quadratic formula, factor, and you end up getting the following. I'm just going to reduce everything, divide everything by 3. I end up getting this. And when I factor this, I end up getting two things. So t is equals to 1 and 3. So basically at 1 second and 3 seconds, you're not moving at that second. So at 2 seconds, the question is asking, are you moving away or towards the origin or the house? We'll use the house. So just because you have something negative, it doesn't mean that you're getting closer or you're decreasing in the distance between you and the house. It really depends on at 2 seconds, where are you at that moment? In other words, you have to figure out, are you here at 2 seconds, here at 2 seconds, or maybe here at 2 seconds before you actually figure out what is happening to the distance between you and the house. So let's find the position at 2 seconds by substituting the 2 seconds into your position. So you're going to take s at 2, you sub it in, you do all this work, and you will end up with 2 meters. So what that means is, if you look at the right here, that means at 2 seconds you are 2 meters to the right of the house. All right, and what's happening? Are you standing there or are you moving? Well, according to the velocity at 2 seconds, you're moving to the left. And what that means is you're going to be moving towards the house. You're getting closer to the house. So the next one is talking about acceleration. So acceleration, as you recall, is the rate of change of the velocity. In other words, we're going to have to find the derivative of this function up here, the quadratic. So you do the power rule, we end up getting 6t minus 12. And at 4 seconds, you just sub it in, you end up getting 6 times 4 minus 12 is going to be 12. And what are your units? Now keep in mind, this is meters per second, and we want to find the units for meters per second, velocity over time, which is seconds. We end up getting 12 meters per second square.